11. The following pairs of equations show how the x and y coordinates of a particle vary with time t. In the equations, a, b, and omega are non-zero constants. Which pair of equations can describe the path of a particle moving with an acceleration that is perpendicular to the velocity of the particle at t equals 0 and remains constant in magnitude and direction? If you want the acceleration to be constant in magnitude and direction, then you need to consider that the acceleration is the second derivative of the position. In the case of option A, that second derivative only repeats cosine and sine, so the acceleration is not going to be constant. Same happens with option B. Now, in option C, there is no acceleration. The second derivative of position gives you 0 in both cases. And in option D, the acceleration in each case is 2a and 2b, but the velocity is 2at and 2bt, which means that at time 0, the velocity is 0. So you don't really have perpendicularity between a 0 value and another vector. In the case of option E, the velocity, which is the first derivative of position, will be ai plus 2bt, and at time equals 0, that is ai. So the velocity is completely horizontal. On the other hand, the acceleration is the derivative of that, and that will be 0i plus 2bj. Now, since it doesn't have any time component here, then the acceleration is constant, both in magnitude and direction, and that acceleration is completely vertical because it is in the y direction only. So the velocity and the acceleration are perpendicular to each other at time 0, and the acceleration is constant in magnitude and direction. So that is your option E.